Alright, I'm in my exercise physiology book on page 81. This will be the winning edge 4.2. Exercise physiology applied to sports. Carbohydrate feeding via sports drinks improves endurance performance. The depletion of muscle and black carbohydrate stores can contribute to muscular fatigue during prolonged exercise. Therefore, can the ingestion of carbohydrates during prolonged exercise improve endurance performance? The clear answer to this question is yes. Studies investigating the effects of carbohydrate feeding through sports drinks have convincingly shown that carbohydrate feeding during submaximal 70% VO2 max, long duration, 90 minutes or greater, exercise can improve endurance performance. How much carbohydrate is required to improve performance? In general, carbohydrate feedings of 30 to 60 grams per hour are required to enhance performance. Current questions include whether the addition of protein to these sports drinks will provide additional benefits to performance. You will see more of this in chapter 23 in addition to the role of carbohydrate loading in the days prior to performance endurance races, marathon. So that was the winning edge 4.2, but I've got to read Ask the Expert 4.2 as well. The lactate, this is on page 84. This dude better be good. Lactate shuttle, an important concept in muscle metabolism during exercise. Questions and answers with Dr. George Book. Dr. George Book is a professor in the Department of Integrative Physiology at the University of California, Berkeley. Professor Brooks is an internationally recognized exercise physiologist, and he has published more than 200 scientific papers on a variety of topical topics related to exercise metabolism. Dr. Burst first coined the term lactate shuttle in 1985, and his laboratory performed much of the original research that defined the role that lactate plays as a fuel source during exercise. Dr. Brooks received the American College of Sports Medicine Honor Award, the highest award offered by the organization, for his major contributions to our understandings of exercise metabolism. Here, Dr. Brooks answers questions related to the production and fate of lactate produced in skeletal muscles during exercise. Question: the concept of the lactate shuttle originated from your work over 20 years ago, and your research group has continued to provide new information about this important topic. Given that the concept of the lactate shuttle continues to evolve, what is your contemporary definition of the lactate shuttle? In the broadest sense, the lactate shuttle is defined as the formation of lactate in one cell compartment and use in another compartment. That is, the compartments may be in the cell that produced the lactate or in the adjacent cells or far removed cells in the body. Originally, we believed that the main function of the lactate shuttle were to provide oxidizable fuels and glyconeogenic precursor. Now we also recognize that lactate is a signaling molecule and may serve other functions in the body. Question: which body tissues receive the most benefit from circulating lactate during prolonged exercise? This is a difficult question to answer. Nonetheless, most lactate formed during exercise is used as a fuel in slow type 1 skeletal muscle fibers and heart. Further, liver uptake of lactate from the blood is important because the use of lactate to form glucose, gluconeogenesis in the liver, is a basic and important physiological process, for without it, hypoglycemia could occur in prolonged exercise. That's cool. Question: in addition to your original concept of the cell-to-cell lactate shuttle, your group has recently discovered the existence of an intracellular lactate shuttle. Can you please provide a brief description of the intracellular lactate shuttle? The original cell-to-cell lactate shuttle was based on a concept of the fiber type heterogeneity. The original idea was that the recruitment of fast-twitch fibers, type 2 fibers, would result in lactate production, thus providing fuel for adjacent slow type 1 muscle fibers in the heart. However, it became apparent that the lactate shuttle operated all the time, even at rest when type 2 muscle fibers were not actively contracting. So we recognized the presence of another component of the lactate shuttle, an intracellular component. In the most simple terms, the intracellular lactate shuttle refers to the concept that lactate can be produced within the cytoplasm of the muscle fiber and then taken up by the mitochondria in the same fiber for use as a fuel source. Question: is lactate shuttling always beneficial? So far as we can tell, in normal physiology, the answer appears to be yes. However, we have recently shown that lactate transporters exist in cancer cells, including mitochondria of cancer cells. One way to think of cancer cells is that their runaway cell proliferation is fueled by lactate shuttle mechanisms. In fact, recognizing that fact, one group has shown that poisoning lactate transport proteins is one way to kill cancer cells. Hence, today we and others are trying to figure out ways to disrupt lactate shuttling in tumors. In our laboratories, Raja Hussain has been the first to explore ways to identify mutations in cancer cells that give rise to changes in the expression of MCT and LDH isoforms, and thus the Warburg effect is rapidly proliferating cells. At present, Raja is exploring the use of methods including chemical agents and viral transfection to retransform cancer cells to those with a normal phenotype. This approach is insightful and important as it is essential to kill cancer cells without harming the host. Thank you, Dr. George Brooks, for that interview and your time. We look forward to hearing more about your research in the future. Alright, so that was page 84, Ask the Expert. And a closer look, 4.2. No, the Winning Edge 4.2, page 81. See ya.